Hello, everyone. Welcome. My name is Rebecca McNamara. I use she, her pronouns, and I am Associate Curator at the Frances Young Tang Teaching Museum and Art Gallery at Skidmore College. I'm also a 2023 Lenore G. Tawney Fellow with the John Michael Kohler Art Center, and I'm a member of Service Design Association's Exhibition Committee, and really excited to be here with you all today, and excited to be here with you, Ursula.
Hi, everybody. My name is Ursula Woles. I answer to all pronouns. My professional home right now is River Sound Solutions. You can find me on LinkedIn. We're updating everything on our website. I consult on and build educational software through which people can be creators with rather than consumers of technology, and that's a lot of what I'm going to promote today. As background, I have a PhD in artificial intelligence that I got in 1991, but I've been teaching computer science in one form or another and interactive multimedia since the 1970s. Rebecca pointed out that it's my 50th anniversary, and that's kind of terrifying. For almost a decade now, I've studied, taught, and consulted on how the fiber arts inform computer science and how to build computing tools that support human-driven fiber arts in textile production.
So before we get started, I have a few announcements. Textile Talks webinars are brought to you by the International Quilt Museum, the Quilt Alliance, Studio Art Quilt Associates, and Surface Design Association. On behalf of the organizers, we are honored to bring you free and inspiring Textile Talks programming. This is a webinar format, so your screens and mics are not active or showing. Please ask questions anytime, and if we don't get to your question during the presentation, please know that we'll save time at the end for more Q&A. There are three primary ways to engage. You can use the Q&A box located at the bottom of your screen for questions. Use the chat box for greeting others, and I see lots of you are putting in the chat right now where you're calling in from, which is awesome. It's so good to see such wide geographic variety here. But please note your chat comments can be seen by everyone, so we respectfully ask you to be courteous as you engage with participants. And lastly, the survey is for commentary or ways we can improve. If you prefer not to see notifications from the chat, you can click on the chat button to toggle them on or off. Okay, now on to AI. So welcome to Fiber Artists versus Artificial Intelligence, what we know that it doesn't. The plan for the next hour is that we'll start off by introducing ourselves and how we came to collaborate on this topic. Ursula will explain to all of us what artificial intelligence actually is, and will provide some examples of how we as human fiber artists operate differently and generally better than current AI. And then we'll have around 15 to 20 minutes for questions and discussion. And Ursula and I have agreed to keep each other on track during this time because we both have a lot of passion for this topic and tend to rant and ramble. So we might have to interrupt each other a few times. So as I mentioned, I'm an art curator and I have a special scholarly and personal interest in fiber arts. In addition to studying textile history, especially in the United States, and as it relates to women's history and underrecognized artists in contemporary art, I am also a hobby crafter, making in cross stitch, knitting, and most recently, though not very much yet, weaving. And so with these interests, it was inevitable that I would also soon learn how fiber arts and technologies intersect. In 2022, I curated the exhibition Radical Fiber, Threads Connecting Art and Science, to demonstrate the ways that fiber-based practice has directly impacted scientific theory, research, and pedagogy. And part of this project specifically explores the history of fiber arts and computer science. I learned about Ursula's work in this area and invited her to participate in a panel discussion on the topic, the transcript of which I'm excited to say is now published in the recent Radical Fiber catalog. And so since that panel talk, Ursula and I stayed in touch, and we quickly realized that we were both frustrated by the fear-mongering media coverage around artificial intelligence. And we knew that our experiences with fiber arts, sharing knowledge in craft circles, and the slowness demanded by the medium had something to teach us about this latest technology. So to set the stage for today's conversation, I want to read a quote by Ursula from Radical Fiber. We need to get technologists and computer scientists to think seriously about what traditional craft communities have known for literally millennia. Computer science did not start with a jacquard loom. Computer science and the notions of pattern, repetition, and variation, which is all that an algorithm really is, was invented millennia ago by the first weavers, sewers, and embroiderers. Ursula, I'm excited to turn it to you to tell us more.
Thank you. When Rebecca asked me to say something about myself, I realized it's better in pictures. It's a very complicated story. Way over on the left is a skirt that I knitted in high school. You can see that it's got some problems. Down below that is a quilt that I designed and created in college 40 years ago. It's not finished yet. It's going to take the prize for least finished piece and a contest later this summer. What comes next is threads and connections, just some images from various things that I taught that evolved into this curriculum called code crafting. And there's some examples in the middle there. And most recently, through my friend Arlene Marin, I've become fascinated by the patterns in quilts. Oh yeah, and that little thing in the middle there, I actually had the privilege at SIGGRAPH, this big computer science conference, to use some embroidery technology to have a drone draw some graffiti. Next slide, please. We thought we would start with some definitions, and I've sort of turned this into a history just to ground things, is that computer science is a relatively young field. Some people argue that it was born around the same time I was. Full disclosure, that was not quite 70 years ago. But we start with algorithms and data, and the seminal work on this is a book called Algorithms plus Data Structures equals Programs. That's all there is. There's data and there's algorithms. There are two kinds of algorithms. There are deterministic ones and the heuristic ones. That pretty pattern you see up there in the corner was computer generated. It's a rendering for an embroidery machine, and it's deterministic. That scary little thing at the bottom there with a lot of math in it is a neural net. And that's where modern AI has gone, to these tiny little creatures and a lot of data. And most recently, really, it turned hot around 2020 is this notion of generative AI and large language models. So when you hear people talking about AI, at this point, mostly they are concerned with generative AI and large language models. So if we could go on. Next slide, please. Okay, algorithms in the fiber arts. You all know this. I picked this one because it had a lot of detail in it. This is a pattern for a granny square, which is going to play significantly in what we have to say coming down the pike here. And you're not intended to be able to read this, but what you can see are two different formalisms, two different languages for talking about what a granny square is. And what's important here is to see that at the top, we define the data, the materials we need, we define our terms, and then there are two different representations for how you would build it. But what's really important is that this is sort of a generalized plan, right? I can build many, many different kinds of things with a granny square. Let's go on. Next slide, please. To reinforce this notion of an algorithm being a set of steps, I pulled some examples from Turtle Stitch. And the website's very simple. It's turtlestitch.org. It's a wonderful, wonderful tool for teaching embroidery and for teaching computer science. And it's based on Scratch, which you might know about. You might have seen your middle schoolers play with it. You might have played with it, barely in middle school. So way on the left is a very simple algorithm, step by step, to get this little turtle creature to embroider and cross stitch a square. And if I vary the length of the square in that second little example with that polygon, and now if I have a script, a more complicated script for drawing a polygon, I can get that. And then finally, if I have some control structures involved, like a repeat, if I repeat 90 times to 10 times to do that polygon, oh, there's a bug in my program. That should only be 6. Okay, I get another really interesting drawing. And this is just the start. These are very simple algorithms, but what you can see by that real piece of embroidery all the way over on the right is that there's a real synergy between defining how a piece of textile art is going to be produced and this notion of data and algorithm. Next slide, please. Oops, we lost one. Okay, now this is where it gets fun. This is where
Did I
the
go in the
AI
wrong direction,
No,
Ursula?
you're right on target. Thank you. Okay, way up there on the left, that little Y, that's a branch. Okay, and a powerful piece of computer science, in fact, what runs the internet and what runs Google search or whatever search engine you use, is this notion of choice. I can go to the left, I can go to the right. Robert Frost had it right. There are 2 roads, they diverged in the yellow wood. And you make a decision about which way to go. What traditional old-fashioned AI, the stuff that I learned in graduate school and also the stuff that I have a PhD in, thinks about these kinds of problems in terms of recursion, that I have a tree and it has a couple of branches and the branches have branches, and you can see a very deterministic one over there in the left-hand corner where my perfect little tree always turns to the left 45 degrees and always turns to the right. And there's a limiting condition. There's a point where we say, uh-oh, we can't get any smaller, let's stop. Okay. Now that idea of which way to go, okay, or to follow one branch and then come back and then follow the other branch and come back is known as search. And some of us would claim that 90% of computer science is about search. And some very brilliant educators who taught me will assert that very, very carefully and claim that all search reduces to something called a Turing machine. And because of that, things are fundamentally algorithmic. Okay, this is important down the road. The examples in the middle, if you look carefully, those are just my tree spun around a circle. That's all they are. Okay, but they produce amazing patterns, and the patterns they produce are remarkably like those that appear in about 6 different cultures around the world. But that's all deterministic. It's very precise, it's very accurate, it's always the same. I can vary the parameters, but it's always the same. Now on the right, you see a rendering of some trees. But in this case, the angles are kind of funky, okay? And if you look carefully, the lengths are kind of different. And in fact, the one that I drew originally and the one that I finally embroidered, they're not the same. Yeah, I cheated a little bit. On the other one, I decided to vary where they start. But even that was based on a heuristic, a rule of thumb that said, well, decide to go somewhere between these 2 angles, okay? And in computer science, we call that randomness. We say there's a probability that your number is going to land somewhere between 10 and 20 or 0 and 1, okay? And that probability is really important for thinking about AI, because what AI does, which mainstream algorithmic computer science, deterministic algorithms do, is it has that little bit of guessing going on in there, okay? You get to that juncture, and instead of saying, okay, my rule says turn to the left and then turn to the right, we say, I'm going to go this far to the left. I'm going to flip a coin and decide to go to the right, okay? It's that probability of not knowing exactly what's going to happen, but just taking a good guess. That's the foundation of AI, and what distinguishes AI from pure computer science or traditional deterministic computer science. You're going to hear me abuse vocabulary because even within CS, we abuse vocabulary everywhere. And we'll come back to that one a little bit later too. Next slide, please. Okay, so just to intimidate you, no, seriously, I'm not going to explain these in details. But if you squint at them, what you will notice is that each of these different examples have an input and an output. And the one on the left is this little critter called a neural net, which is not, absolutely not based on the neurons that are in the brains of living things. Okay, it was an attempt to do it, But as my mentors at MIT many years ago explained, this is a hypothetical concept. But what you'll see in the popular press is that it was modeled after the neurons in our brain. No, no, no. Let me disabuse you of that. You take a whole bunch of those and you create banks of them. That's in the second one. Okay, you have a whole bunch of inputs. They do all kinds of stuff. And depending on how those little coins were flipped in between, based on some weighting schemes that can be adjusted, it filters through a hidden layer and an output layer, and the answer comes out the other end. We have input, we have output. Now, the thing over on the right is what has created the hoopla about generative AI. That is a transformer structure, and it was co-developed by some researchers at Toronto and at Google. And the idea behind a transformer is that we start with some input. We do a lot of this coin flipping, basically, on a huge data set, and an answer comes out the other end. And I'll actually illustrate that a little bit more later on. But at its core, what we have is input and a process and output, otherwise known affectionately among those of us who study this stuff as garbage in, garbage out. What happens in the middle there is only as good as what came in. Next slide.
Ursula, I want to just pop in because somebody asked a question in the Q&A, and I think I know the answer, but just needing a bit of clarification. CS, which stands for computer science, is following the pattern to the left and to the right, and AI adds in the quote randomness somewhere between the left and the right question mark. Is that?
Yes,
okay.
And that is a gross
Melanie, you got it.
yes, yes, it's a gross simplification of the world, but down the road, I think we're going to be able to show how what fiber artists do doesn't need the randomness. Is that we're not, anyway, we'll get there. Yes. Next one, please. Okay, Rebecca, you got this cool example.
Yeah, I have a fun example. I did some experimenting. So as Ursula and I have been talking for the last couple of years, and you know, my innate cynicism latched onto her cynicism about and skeptical nature about what was happening in AI and about ChatGPT in particular. I thought maybe I wasn't being totally fair, if fairness to a technology even matters, morally speaking. But I decided to give it a shot. So I wondered if I could make an oversized granny square that could be shaped into a dress. You can see two instructions from me, and then I truncated the pattern to the assembly part for the purposes of this slide. And I realize some of this text might be small if you might be viewing it on a smaller device, but we'll read out the most relevant parts, and you can always look later on YouTube after the presentation is posted. So ChatGPT first says the corner, so a granny square is a square, fold it, and the corner is the neckline. Then it says the folded edge is the neckline. So if it's the first thing, if the corner is the neckline, I suppose the straps that it calls optional are actually mandatory, because else how is it staying on my body? If it's the latter, how do I fit my head and neck through what is ostensibly a solid surface? So think about that. Granny squares have holes, to be fair, but not ones that are made for a head and neck. A fold is solid, and I, a human person, cannot go through a solid. So I had done that back in December, and before this presentation, I thought, well, AI is moving so fast, let me just try this again. So this time it asked me only to fold the edge to be the top of the dress, then said that fold would be the neckline. So this still is not making any sense at all, but let's keep entertaining the pattern. Okay, I'll make the square, I'll make the fold that my body can't go through. What size granny square should I make for a person of my height? 5 feet, 5 inches. And the ChatGPT responded that the square should measure 36 to 40 inches. That might make sense, except once I fold it in half, that really does not seem big enough. Not to mention, again, this triangular shape that it's creating with the square also doesn't make any sense. So there were other issues with the pattern too that I'm not going to go into, but to confirm my suspicions just about these particular aspects, I did something a bit silly and I created a scale model on a doll. So I scaled the doll's ratio to my height and made what would be the equivalent of a 40-inch, so that longer part, square. Steam blocked it and everything, did the whole thing. So you can see that the sizing barely covers the bits that dresses usually cover. And you can imagine the dress definitely doesn't cover the full bum. And then you might imagine what would happen if you wore this on a breezy day. Not ideal. And this is what happened when my doll tried to get the dress over her head through the fold. To be fair, I did not finish the pattern and seam up the edges, but if I had, we'd have armholes, but we wouldn't have leg holes. And again, there would be no way to actually get the folded fabric onto the doll. Now, if I had asked a crafter friend instead of ChatGPT, that person might have suggested I stick to using 2 large granny squares or helped me troubleshoot with some paper templates in real space to create a pattern that actually worked with the human body. Maybe I could have made a cylindrical shape with the square using some straps. Who knows? But there are functioning possibilities to be sure. What I ended up doing was purchasing an excellent pattern online that uses 2 oversized granny squares, and then I adjusted it to accommodate the specific yarn and color scheme I want to use. I adjusted it as I crocheted to make some changes that I liked for the shape. But ChatGPT, not it on this dress. So Ursula, tell us what went wrong. What is actually going on behind the scenes of a program like ChatGPT, and how does that relate to the definitions you shared earlier?
I will back up, stay on your slide for a second. Okay, so I'm going to read this one so I get it right. Okay, Gen AI LLMs, generative AI large language models, attempts to mimic language. It doesn't have language. All it does is translate a string of symbols into tokens that have no inherent meaning, that are run through a heuristic. Remember that heuristic thing, algorithm, that determines the physical locality of the tokens in the input stream. Okay, it doesn't even know what a sentence is or a paragraph. Okay, they call this technology transformers that reason about context. Okay, they've anthropomorphized it. It does not reason. It does not have context by the definition of any good philosopher or English teacher. Okay. But this is not context as we know it. You don't talk about dropping stitches when you are designing patchwork. By context, what we really mean is statistical locality. How close are those 2 tokens to each other in a whole bunch of examples? Okay, now we can go on to the next one. Serendipitously, while we were going back and forth about this, my friend and hairdresser and consummate artist, Robin Hollister, shared this jacket with me. And you don't really need to read the full chat, but what's important in the chat is she says, I would check to make sure that she hadn't just copied it from right there. And sure enough, like all of Robin's work, and it's beautiful. She looks at something and then she makes it and then she adapts it. Okay, and what's really important about this particular conversation, okay, is that she admits, well, it's not done actually, contemplating pockets and cuffs on the sleeves. And then I wrote back, well, I'm typing. Okay, she said, I just went with what I know, didn't write the pattern down yet. Okay. And while we're in this conversation, she's thinking, although I really like 3/4 length sleeves myself, so maybe no cuffs, but I do love pockets. And then she said, oh, thanks, because she amazes me on all levels. So let's go on to the next slide. So for grins, because that's what Rebecca and I were up to, I went to ChatGPT on my iPad, which is important. And I said, design a hexicardi. Oh, because in that last little dialogue, she told me this wasn't a granny square, it was a hexacardy. I didn't know what those were. And what GPT came back with, because it got hung up on the locality of the word designing. Designing on ChatGPT is about building things, about building software and hardware. It said designing a hexacardy, a hypothetical medical device for analyzing heart function from multiple angles. And it goes on for 3 pages, defining a totally absurd piece of hardware. I happen to be playing with medical devices in another context. This one doesn't work either. Next slide, please.
I want to just pause in a second to emphasize something that you said, which is that when you asked your friend Robin about a granny square, she said, you're not looking for a granny square, you're looking for a hexacardy. And that was because you hadn't made one before and didn't know that language. When you asked or told ChatGPT design a hexacardy, it spit out what it knew. There was no possibility of it saying, right? Yeah. Go ahead.
So yeah, I called you on it, Rebecca. It doesn't.
What did I do?
It doesn't know anything.
It doesn't know.
All it does is it goes down its search list and says hexacardy. Can't find it. Designing. Know about designing. I must have to design something called a hexacardy. Okay, because it didn't have that anywhere in its previous vocabulary. It had no way of saying, no, not a granny square, a hexacardy. And it had no way of really teaching me about something new. That's not built into the, it's not remotely baked into the architecture. So let's go on. Okay, but like you, it was able to adjust what Robin did was exactly what you did in the general case, where you took what you had and you figured out how to remix and adapt it and make it your own and invent pieces that you hadn't seen before. Okay, and that's what the AI can't do, absolutely cannot do. So
now I ask you your favorite question, which is, can ChatGPT be trained to understand things like necks can't go through solid surfaces, or can it be trained to understand what a human body is and how they work and how physical space works? And what is artificial intelligence training anyway?
Okay, well, let's see what I forgot what I put on the next slide. Let's go see what's there. Okay, first, AI. All right, artificial intelligence is a subset of computer science. There are about 40 other components to what falls under the rubric of computer science when we tried to teach it at the undergraduate level. There are essentially 2 types of AI, and people will argue their brains out about this at this point. There's symbolic learning logic algorithms, AI, which is the stuff that I did in graduate school and that I continue to dabble in. And that's where natural language generation from a semantic standpoint comes from. And we are doing the Sisyphean task of trying to actually represent language in a computer. I'm doing that now in a tiny domain. It's next to impossible. I have done it as part of a system called Stepwise where we mapped all of Common Core mathematics. Okay, beastly system, took 10 years. Okay, similarly, the reason robotics is a little bit smaller is that robotics takes from AI, but there's also a lot of other computer science and electrical engineering and mechanical engineering that contributes to robotics. But smart robots, okay, are primarily still part of symbolic learning and logic algorithms. On the other side, we have this notion of machine learning and big data. Remember that little thing that I put out there, the neural net, okay? And for the most part, until fairly recently, there was a balance between statistical learning and big data and data science and neural nets, convoluted neural nets and deep learning, okay? And in the last couple of years, Gen AI with large language models also falls into that domain. It's a very small piece of AI. So let's go on.
Before we do, I just want to address two questions about this slide in our Q&A. And they're related, so I'll read them back to back. Allison is asking, wouldn't it, quote, learn from the mistake of its analysis, and then the information would be available for another question? And Karen asks for a definition of what is meant by learning when you use the word learning in this context.
Okay, when I use the word learning, and I've been told that I wasn't called neuroscience when I got my degree, but at this point I would have gotten a degree in neurosciences. When I talk about learning, I talk about the magic, the absolute wonder of what natural learning is. And it's me, it's my cockapoo sleeping over there blessedly. It's the iguana out in the pond. Okay, we learn from our experiences. When there's a novel experience, we are able to adjust to it. In the next couple of slides, I hope to show you that the architecture of Gen AI large language models doesn't allow you to do that. The symbolic learning logic algorithms on the slide is purely taught. We program it to have decision structures that can generate new things. Or generate solutions. I want to be careful about my language too. The danger right now is everybody's anthropomorphizing the systems, and I caught Rebecca in doing it too. Understanding, knowing, learning, even on this slide, okay? It's not happening. Data in, process, data out. And I'm going to be burned at the stake next week for being that blunt about it. Okay, so no, it can't learn from its mistakes. And I think we might be able to demonstrate that really profoundly in the next couple of slides. So, okay, so yeah, this technology is just in its infancy. And so the theory says that if you get enough sentences, you can look at the relationships between them. And I love this example because it's been touted in a whole bunch of different articles that the proponents of AI put forth. Okay, and the idea is that we can disambiguate language if we can just understand the locality. Okay, so what's happening on the left is they're saying, I got this sentence. I don't know whether the teacher taught the student and the teacher had the book or the student had the book. Okay, and what they're showing on the right with this pretty little piece of embroidery that I wanted to build for you all, but I had other things to do over the last couple of weeks. But I'll build it. It'll be out there eventually because it's a cool piece of art. Is this notion of the predominance of particular relationships. Okay, so what you can see here is the book and the teacher are somehow related. The teacher and it's that locality that they're somehow claiming produces it. Now, what an English teacher would tell you is just put the commas in the right place. Okay, and that's been a problem with knowledge representation and learning and knowledge acquisition, is that human and natural learning is so rich and squishy and wonderful. And the machine is fundamentally mechanistic. And I will tell you, full disclosure, that I've only fully been able to try to articulate that in the last couple of weeks while we prepared for this event. So let's go on to the next one. Okay. Is it going to get any better? No. All right. And here's the answer to, well, can't it learn? So I went back onto ChatGPT a couple of days later, but instead of going on my iPad, which is logged into one of my accounts, I went to another one on my computer, which is logged into a different account. So the two contexts, remember that word, were different. Okay. And so I said hexicardy. And first it tells me, I think you misspelled this. Okay. And then when I say, no, this is a crochet term, it gives me this stuff about crochet in general. But it doesn't know anything about hexicardy, even though 4 days before I had brought up the idea, right? And the fundamental flaw in the architecture here is that it looks its stuff up, it makes a good guess. There, I did it, I anthropomorphized it. Looking up is allowed, okay? It flips a coin about how it should proceed, and it goes with it, but it's so authoritarian. Look at how authoritarian it is. It's got to be my fault, the human's fault, that this doesn't, I don't know it, so it doesn't exist. Okay. Keep that thought in mind. Let's go on.
Can I also point something out / ask you a question about this? as humans, we learn context clues and deductive reasoning. So if you say to me, oh, have you ever made a hexicardie? And I haven't heard that term before, I can understand, oh, cardie is short for cardigan, hexi, oh, you're talking about something with a hexagon. How does a hexagon styled cardigan? Like I can use my own reasoning skills to figure it out in conversation in a way that AI cannot.
Yeah, and Alice Ellis just asked a question. I can't see the bottom of it, but the top of it says, if the AI model has been trained with textile and crochet. Oh, this is the tip of the iceberg. Rebecca and I have been playing around with this for a while, and in fact, there's a wonderful published example of how it completely mangled a half square triangle pattern, and instead produced a very simple 9-patch. So the problem is that for me at least, patchwork is a beautiful domain to think about the limitations, because the language is so complex. And if you know the language, you can produce almost anything. And you can discourse with people. And again, we slid an example of that in here. So it's this question of training. It's who trains it and how do they train it? And we'll talk about that a bit more in the future. Oh, it's right here. Okay, so this is the example. Arlene Marin rescued me. I thought I kind of knew something about quilting, and I had a quilting project, and now we collaborate a lot on quilts, and we go back and forth. We probably have 2,000 messages in a chat chain because now we live 200 miles apart. She sent me this late last night. The quilters at the Unitarian Universalist Church in Montclair are making a baby blanket. And on Saturday, they cut fabric and made it into packets so everybody could disperse and make their piece of the quilt. If you're a quilter, you get this, right? You share, you collaborate on the project. But they went back and forth, and Arlene's original pattern, I told her, was way too complicated to give to the women in this group. I'm the youngest by 5 years. Okay, and the oldest is stronger than any of us and much older than I am. And so this is where she ended up. Okay, and it's very straightforward. It's very simple. There was a nice example of it, which I didn't put on because we don't own the picture. And it's straightforward. It's 4 seams, I think. But what's really important is look at that last line. Okay, after the top is sewn, we will decide on the border. Okay, 5 women over the course of a couple of months will produce a precious baby blanket. Okay, there's no training going on here. You know, there's no, here's a big data set, generalized from it. It's about the back and forth. It's about the constant refinement. Okay, it's about learning from each other that really informs the way that fiber artists, whether they are doing this for the beauty of the art or whether they're sitting in a factory sewing a seam. Okay, I have a couple of friends in the textile industry. My uncle was as well. And what's really important, and we're going to move on so we have enough time for questions because we've covered a lot of what we're going to cover. What I learned in his factory in Venezuela 40 years ago is that you listen to the people on the machines because they know how to make things better. Well, Venezuela's a mess right now, but that's because they didn't really get that. So let's move on from there, but I really do appreciate that question. Do you want to jump with this one or should I?
I can get us started. So these 4 words were words that some of you might have read in the description of this talk: react, reason, decide, which you've now grayed out, and recover. And these are words that were just regularly coming up in our conversations of trying to sort of talk through what it is Ursula and I do as fiber makers, how we respond, how we identify issues, how we respond to issues, how we problem solve, and really honed in on these words, maybe minus the word decide, which Ursula will talk a bit more about, as things that we can do as human makers that it does not seem possible for AI to ever achieve. So Ursula, do you want to kind of respond and maybe elaborate a little bit on that?
I think where I want to respond is the reason I asked to gray out the decide yesterday is that you could say that that simple decision point is deciding. Okay. But we're talking about something much more subtle here. We're not talking about being trained to pick a particular probability. What we're talking about here is I'm going to move forward on this. And Arlene's statement, we will decide about that later, knowing what you can plan out ahead of time. Over the last 5 years, I've been involved in about 7 group projects in embroidery and quilting and crocheting. And we are constantly refining what we're doing. We have never set out with a plan that we can just execute. And that's the flaw in generative AI with large language models, is it gives you an answer. And it can refine the answer if you give it more information, but it's still just picking the words that are closest. Rebecca, we're at the 42 mark, and I want you to talk about your stuff. So, and I want a chance for us to really get into the Q&A too. So I think we've beaten this one to death. We are making the statement that that subtle, complex stuff that fiber artists do is not constitutionally what generative AI with large language models can do. So let's go on a little bit. We can go past, yes, please. Yeah.
So I just want to talk really briefly because we've been focused on functional arts, and I want to address arts for viewing. So for beyond the wearing or the use in the home. So as Ursula has explained, AI can only output based on what is input. Therefore, it cannot innovate in the way of a human artist. And in order to innovate, particularly in fiber arts, I would argue, although you could potentially argue otherwise, but generally one needs to have a pretty deep technical knowledge of the possibilities of the craft that you're working in. And I've been recently doing a lot of research on Lenore Tawney, which is why I'm using her as an example here. She's a pioneering 20th century artist who became renowned for her open weave technique and moving her weavings away from the wall to create a more sculptural sensibility. Later, she would create quote unquote weavings that were open, loose strands of yarn hanging from the ceiling. She also incorporated feathers and rocks and things she found, eggshells from her morning breakfast into her weavings, things that have personal, cultural meaning to them. So it is art that moves us spiritually, creatively, emotionally when we see it, and especially when we see it, of course, in real life. And so before she was innovating, she was trained at a number of institutions and pored over her loom daily to really understand weaving techniques. And she read tons of texts and would pull out quotes that were meaningful to her or that she believed might be meaningful to others. So she had this technical ability to understand weaving and the physical and experiential ability to understand how humans interact with weavings, and was able to use all of that knowledge, real knowledge, in a new way, to envision a new way of creating artwork with fiber. And the same can be said of so many other artists. And another thing that artists can do that AI cannot is respond to current events and use materials in intentional ways that bring together nuanced historical and contemporary references. So this is an image that was part of the Radical Fiber Project. This is the Saratoga Springs Satellite Reef, which is part of the Crochet Coral Reef Project by Christine and Margaret Wertheim and the Institute for Figuring. It is a community-made artwork that brought together hundreds of new and seasoned crocheters who gained knowledge of mathematics, crochet, gained knowledge of the plight of corals around the world due to climate change, all through their embodied making, the embodied knowledge building. And it brought people together in craft circles to talk about these ideas and more. So crocheters followed patterns and created their own designs throughout, and the making is what generated the learning. And AI, though it sometimes makes mistakes that might read like creativity. And I'm thinking of, all the six-fingered images of people that we see kind of floating around the interwebs right now. It's not actually capable of real human creativity. And so again, outputs are based on inputs. And if we don't know what's possible because humans haven't envisioned it yet, and we can't input what doesn't exist, how can we generate new ideas? How can we gain knowledge if we allow AI to generate what amounts to pretty crummy and not actually real thinking, which again is that anthropomorphized term. And so AI might be another tool in the artist's toolkit, I don't know, but human mental and experiential and material knowledge, skills, innovation are remaining very necessary to our world.
So where I'd like to spend the next few minutes is asking you all, what are the tools that you need in order to own your creativity? Okay. Today, down the road, get in touch with us. Identify processes that make your work easier, better, richer. Okay, not that oversimplify them or co-opt them in some mechanistic way. Okay, going back to what the mission statement of my company has been, be creators with, rather than merely consumers of the technology. Gen AI is intended to be consumed. It's intended to replace what you do best. Okay, and finally, the other punchline where the two of us started, there is no such thing as rote mechanistic work. It's all creative because you react, you recover, you have insight, you get bored and you lose focus. And that's where I'm going to stop. So we have one really good question here, or insight by Kaylee Perkov. Could some of this—
Perkov, shout out to Kaylee, who also has done a really important exhibition on textiles and tech at the Craft Museum in Asheville a few years ago. It's nice to see your name pop up.
So in the questions, could some of this be boiled down to the difference between tacit and explicit knowledge? Yes, exactly. Even if ChatGPT could acquire better language, remember, it doesn't acquire language, it just reorganizes tokens. It only reorganizes tokens. Better language for instructions. There is still a vast gap between having the language to describe making a hexacardy and physically knowing how to make a hexacardy. Spot on. Okay. You can be able to define these things. You can take the definitions that are on the internet, but understanding how to take things apart and put them back together again is the holy grail of computer programming. How do we do that? Not whether you can read JavaScript. Okay. And the AI can't do that. Another person, I've lost the person asked, so is this a male or a female perspective? Okay, it's authoritarian. I wouldn't worry about the gender so much as that it's telling us it found the answer. Okay. There's an expletive that I would like to use for that, but I get away with that because I'm an old woman. Do we have other questions?
Yeah, there's been a few questions related to image generators like Dolly and what this person, Ellen, asked, could it design a granny square dress as long as the prompt does not include the word design, which you've identified as problematic, and describes exactly what you imagine a crochet dress might look like to the model. I would say just my immediate reaction is like that I have to have a lot of existing knowledge in order to do all of that explanation for the generator, but also an image generator isn't really going to help me with a pattern if I want something to—
I would go try it. I would actually go try it. And full disclosure, one of my best collaborators is someone who has used all kinds of very sophisticated AI and mathematics in order to create the magic of MRIs, which is part of the reason I'm alive, because I had stents put in, and without that, I wouldn't be here. On that note, there's a lot of powerful ways to use neural nets and not large language models, but to use AI heuristic processes The holy grail for us is trying to understand how do you represent it? How do you get it into a computer as data? Okay, and one of the magic things that came out of that was the idea of process as data. Okay, and close. Okay, but those of us who've been working on this for 40 years, we also have the humility to know that every time we think we get close, there's another gap. There's something we didn't see. There's a relationship we didn't see. And I think humility is what we really need in this industry is let's just build some good tools. Okay, you can refine an embroidery needle. All right, I bought some really crappy ones on Amazon about a month ago, and I found a really wonderful one for my mother. Okay, good tools, whether it's the needle or a computer or whatever is coming next.
Related to that, somebody had asked a few minutes ago, what are your thoughts on the need for specific AI platforms for specific textile practices rather than using a more generic platform such as ChatGPT, which is quite interesting in thinking about, and again, like I mentioned, like maybe AI becomes a tool in the toolkit, but it doesn't become the thing. But Ursula, do you have any other thoughts?
Yeah, I've been cagey about it because it's not the project I've been working on, but yes, I'm working on something called a smart curriculum. And the domain of that smart curriculum is the relationship between fiber arts and math. And we have about 40 examples, but they're totally incomprehensible at this point. And there's no Gen AI in it. It's old-fashioned knowledge representation stuff based off of work we've been doing for 40 years. Will anybody use it? Will we get it far enough? I don't know, but we're working on it, so please stay tuned.
Somebody has said that they found AI generated images produced very interesting designs, which then leaves the human the problem of how to realize it. Yeah, I've definitely heard about this too, people trying to track down patterns for garments and things that they see online. And it turns out that that thing never actually physically existed, which is a quite interesting new dilemma for our world.
Right. And so, again, there's this trustworthy component, and we haven't, this is a conversation for another day, is how do you know what it's saying is actually doable?
Yeah.
In a world where you can, well, when certain royals in Britain have decided to fix images, who do you trust? I would like to trust something where I can take it apart and actually quiz it and find out how the details work. And then the other thing that the automatic textile or textile industry is looking at, which is a fool's errand, is to completely automate it and leave the human out of it. Can't work for the same reasons. It can't back up. It can't say, uh-oh, that didn't work. And that's what fiber artists do so well.
React and recover.
Yep. And I want to reiterate what Rebecca said, is that we learn from each other. We innovate with each other, but we're kind to each other when we do that. Okay, the old ladies, when we quilt together, we're yelling, I'm going to use username myriad, you got to rip out that seam, it's not straight. Okay. It's okay, Marriott's fine with that. Marriott can also iron better than I will ever be able to, which is really important. Okay, so you have skills, you continue to build skills, and that's the architecture of living creatures. That's not the architecture that's being built here. Maybe it will be someday. I don't think so. Not in my lifetime, which is not that long anymore.
Are there any other questions? I think that we've touched on everything people have asked so far. We have a couple minutes left if there are any new questions. And if you've, I'm just scrolling through now. Somebody commented, AI does not replace the knowledge of our hands, in some ways the tacit knowledge, but not entirely. There's a question which I think we touched on earlier, but asking why AI is so authoritarian in producing its answers.
I can't touch that one.
Yeah.
I'm a woman in tech. I will not go there.
Yeah.
I stay under the radar for a reason.
Yeah. And there's questions about copyright and ethics too, which is a whole big discussion, probably for another day, but it is worth looking into. You can find some really good articles that are starting to come out right now about copyright because of the ways of what is being fed into these systems is actually in many cases copyrighted imagery, artwork, everything else, and then having something output from it is a new copyright dilemma that I haven't fully wrapped my head around.
Yeah, I've sort of converged on that one because I was in a situation where I wanted to trace by hand a unicorn, and my handwriting, no. And what I decided to do was I traced it on my iPad, one that I found on the internet that I wasn't going to buy and that wasn't free, but I modified it. And then I took my drawing and I pulled it into Turtle Stitch, and I used the Turtle Stitch to draw the image. And I challenged people about it in the Turtle Stitch group, and somebody said, why don't you just do this? And what I realized is that by doing that, my hands weren't involved in it. I was translating, there was a data set there that was translating into another data set. And there was nothing new. There was no innovation on the part of the human in there. I wasn't, when I did it, I wasn't simply taking things apart and then reorganizing them, okay, or taking one data set and moving it into another data set. I was adding to it. When you add to it, that's like copying a master. And I know very little about that stuff. And when I pull images off the internet, I make sure for public talks, I make sure that I've got some link to where they came from, unless they're in the domain. The danger right now is that the Gen AI people are very comfortable with the idea that they can suck the data from anywhere. And there are even people who are showing artists and writers how to embed essentially bombs into their writing that cause their what's being read to be misinterpreted and messed up. So it's a war. Kind of an interesting one.
Yeah. Well, I think we're about at time now. So little dark note to end on, but I think one of the lessons is to also be suspicious. There's a couple of comments flying through Q&A and chat about images people are seeing online and believing them when they shouldn't be believed. And so maintain vigilance, everyone. And thank you for being here and for participating. And yeah, see you again soon.
Hope so.
Thanks, Ursula.
Thank you, Rebecca. This was fun.
This was a lot of fun.